Hi, this is Kevin. I'd like to welcome you to my tutorial on creating custom classes in Python. And I'm doing this for my summer 2017 Python programming course, in which, for the most part, we're working with procedural Python. And we were working with classes and objects from classes created by other people. And at the very end of the class, I brought up the idea that we might want to create classes ourselves. And this tutorial is going to show the creation of a very simple class, kind of a starter class. And let's get started with it. So this class is going to go into a module called counter.py because the class is going to be called counter. So let's start documenting it the way we were doing in the class this semester. And this is a simple tool class that implements a counter that would be used to count attendance. And let's say at a basketball game or a dance. I kind of remember my high school days here. This is a pretty typical thing that that instructors do. I mean, I'm not the first guy to think of doing this kind of a class. Okay. So let's think of what the interface to this kind of thing can be. Okay, because it's really important to understand what the interface is. So again, this is like the little tool that you have. I can remember people having it at the high school dance and high school basketball games. It looked the counter readout looked like the odometer on a car. And it had a little push button clicker, and every time you clicked it, it went up by 1. And it had a reset button that would reset to 0. And ours is going to be a little fancier than that. But the idea was, you're limited in having, say, 500 people in the gym by fire code. And in my high school, we had both the dances and the basketball games in the gym. So you had to make sure you didn't go over that. And this was just a simple tool to allow that to happen. And the reason that I chose this, one, it's a traditional one to do. Two, it just has a little bit of data, and it has a little bit of behavior. Okay, and so you can get the idea of how to implement both data and behavior by creating this simple counter class. Okay, so we ought to be able to create a new one. Okay, so we ought to be able to create a new counter. And when we do it, we ought to just be able to call a constructor on it, okay, and ask for a new counter, okay. And the default is when we create a new counter, it's going to have the value 0. It's going to be reset to 0, okay, because that's a typical use case. I want to support another use case, which is, let's say you're taking over for somebody doing the counting, and they have their own counter and you have your own, and you want to say, well, how far are you? And he goes, well, I'm halfway there. I've gotten to about 250 people. You say, okay, let me set my counter to 250 and I'll take over from here. So I want to be able to send in an initial value, a start value as well. Okay, so I want to be able to construct one with an initial value. Okay, and let's say we're going to put this in some kind of a variable C1. Okay, counter 1. And let's say this is going to be counter 2. It's going to look like that. So that's how we're going to use it. And then how are we going to change the value? Well, let's see. We could do something like this. We could say C2, we could call click on it. Okay, and we would expect the counter to go up by 1. And how we're going to find out the current value of the counter? Well, I'm going to have another method called get value. So you would call get value. Okay. And let's assume that we're going to save that. So we would say x equals C2 get value. Okay. And what else would we like to be able to do? Well, we would like to be able to reset, and we'd like to be able to reset to the original value, the start value. So in the case of counter 1, we'd want it to go back to 0 because it started at 0. That's the default. In the case of counter 2, we'd want it to be able to go back to 250 because that is how we set that up. Okay? So that's going to look like this. Counter 1 reset. Okay. Or we might do counter 2 reset. Okay. And there's one other thing that we'd like to do with these object-oriented classes. We want to make sure that we can get a character representation of their value. So what we're going to do is we're going to implement a method that is going to support. We could say y equals C2. We could say string of C2. Okay. And what we'd expect to get back is something like this counter, and we might have value equals let's see, C2. The value would be equal to 250 because we just reset it, and start value equal to 250 as well. Okay, so those are the usual things that we'd like to do with a very simple class, something like a counter, and that's how we'd like it to behave from the outside. So how do we build it on the inside so that it gives us that kind of behavior? I also want to mention I would like to take a conservative approach to this. There's all kinds of styles of Python, and my style is really influenced by the fact that I wasn't originally a Python programmer. I was well, I've been a lot of programmers, but most recently, before Python, a Java programmer. And Java programmers are more conservative than Python programmers. So there's a conservative sect of Python programmers, of which I am one, who say that we want to protect the data inside these class instances. So we don't want the internals, this value or start value. we don't want people to be able to change them from the outside. Which is to say that if you want to deal with the data that's in a counter object, you have to deal with the methods. And this whole idea is called encapsulation, and it's been very popular with a whole series of object-oriented languages. And the modern Python people have gotten kind of permissive on this, so they don't always kind of enforce this encapsulation that we're going to have here. And that's okay for them, but for me, it's not okay. And I would hope that it's not okay for you either, because I think that this creates a software engineering culture and code sharing culture that is more reliable than I think the liberal Pythonistas can really support. But that's because I'm a conservative guy. So I'm confessing that up front before I share my code. Okay? This is kind of conservative. So the way we're going to implement this class, for instance, you can't change the value of the counter except by when you construct it. Okay, you can give it a start value. Okay, you can change it by click. You can change it by reset, but you can't just take a counter object and access its value field. I'm gonna hide that. Okay, and you can't take a counter object and access directly its start value field. I'm gonna hide that too. Okay, and I'm going to do that because I believe that it follows good software engineering principles, particularly the principle of encapsulation. Okay. All right, so let's do this. So we're going to begin. We're going to skip our 2 lines from the comment, and we're going to begin with a declaration of the class counter. Okay, and that gets a colon. And the first thing that I want to do, the first method I want to define, is a standard one called init. And this is the thing that implements the constructor. Okay. And we do a couple of things here. In particular, we will define our instance variables here. So if a counter has a start value and if a counter has a value, well then I need to make sure that they're defined and properly initialized here. Okay, well it can't have a start value unless I'm going to pass one in. So the first parameter self is always sort of implicit. So when you call it in your calling code, you don't have an equivalent of self. But when you receive the call here in the call code, the first of the arguments that you get, the first of the parameters that you get, is always a reference to the individual counter object itself, and traditionally we call that self. So we get that, but what else could we get? Well, we could get a start value. Okay, so somebody could send in a start value of say 250, like we talked about earlier, or in the alternative, if we just want to create a normal old counter, well, normal counters really start at 0. So how can we do that? Well, the way that we do that in Python is we use named parameters and we give them an initial value. So the start value, we're just going to say it has an initial value of 0. And this is going to say if somebody should code a start value and pass it in, well then they're going to get that start value. If somebody should just say they want a counter paren, well then it's going to have a start value of 0 because we just established that as a default. Alright, so we need some code here. So what are we going to do? Well, we are going to initialize our instance variables. And the instance variables always begin with this prefix self dot. Okay, so that means the variable that's in this instance. And we're going to create a variable called __ start value. And you may say, oh, well, that looks kind of arcane. And it looks like that __ init. And it's the same kind of idea. The init method, it can't be called explicitly. It's only called to initialize the instance variables when we construct a new counter. So we have the same thing with variables. If we want to hide them as well, we can give them a name that start with __, and that doesn't make them impossible to access, it just makes them inconvenient to access, and that's really good enough encapsulation for me. So what are we going to assign the internal the instance variable start value? Well, we're going to assign it the start value parameter. Okay, and because that's a parameter to this method, the name is going to be known within the method. So this is going to be equal 0 unless they provided another value. Okay, that's great. So we're going to use the start value as the start value, and we're remembering it. Okay, and of course we need a value as well. So that's going to be self under value, and of course that's going to get the start value too. The difference between these two instance variables is value is going to be affected by the click method. It's going to get higher and higher. But start value is going to stay the same all the time. And it's only going to really come into a consideration if we want to call reset on the counter, in which case it's going to go back to its start value. Okay. All right, so we have that. Now what other kind of methods are we going to need? So we've got the data defined, and we also have it properly initialized. So what kind of behavior do we need? What proper methods do we need? Well, remember I said that we need to be able to reset. So let's define a reset. Okay, and you'll see the tool here is automatically saying that we get the parameter itself because it knows it's an object-oriented method. Okay, and what's going to happen then? Well, what we would like to do is we would like to set value back to the start value. Well, that's easy enough to do. So we're going to say self __ value is going to get assigned self start value. That's pretty easy, right? And notice how this method, it doesn't have any preceding underscores. We're not trying to hide it. It's easily exposed. It's easily discovered. It's easily called. It's easily, you just call reset on the object. All right, so we're able to reset it. Now what else do we want to do? Well, what if we want to get the value? Okay. Now, with Python programmers who are not as conservative as I, they'll just let you reach into your object and access the variable value. Okay, but since I've been more conservative in this kind of software engineering side, and the value instance variable is not very visible, well, you're going to have to call my getter method. Okay, and this is a conservative approach. All right, I confess it and I recommend it. Okay, so it's going to be called get value. Okay, and because it returns things and it's just going to get the value from this object, we're not going to pass any other parameter in other than self. And what are we going to do? Well, we're going to return what's in the instance variable underscore underscore value. Okay, it's that easy. Sorry, self under value. All right. Okay, so that works fine. Not a whole lot of work to get some software engineering robustness value. Okay. All right. And what else do I need? Well, I need a click. Well, click shouldn't be too hard. First of all, I don't want to obscure the name, so I'm just going to call it a click. It's going to get the self parameter, and I don't have any information to pass in. I don't really need any information back either. I just want some action taken. Change the state of the value by incrementing it by 1. So how could I do that? Well, I could say something like this. Self dot underscore underscore value plus equals 1, which is the same as saying self value equals self value plus 1. So that's pretty good. So that's let's see, we can construct a counter with a default value of 0. We can pass in a specific value, 250. We can do a click. We can do a get value. Up here we didn't have the parens on the get value. We can do a reset. Oh, and you know what we don't have yet? We haven't implemented the string yet. Okay? And before I implement it, I'm going to show you that you can actually try to turn a counter into a string, and you'll get a string. It's just not very appealing. So then we'll code a string method here into the counter class and have it look a little better. Okay, now here's the thing we want. I'm going to follow the general practice of just simply putting my test code for the counter class in the same module as the counter class. And this is not super sophisticated testing. In more sophisticated unit testing, I would probably put the test code in a separate module, and I would probably be using a true testing framework with a test runner and all that kind of stuff. And of course, we haven't covered that in the class this semester. So what we've been doing is we simply create a main. So we define a main method, and in that we put our test code. And down at the bottom, we've been putting some code here. Let me open up a recent project. Open recent. No, I can't find it. I was going to try to steal some code, and I'm not seeing the code popping right up. So let's see. The code that we want is we want to call main if __ name is equal to __ main. So this will call our test code to be run only when we are testing the module. So __ name equal, and we're going to say __ main. If that's true, then we're in a test the module state, and so we do want to call main that's going to have our tests in it. Okay? And let's do the following. Let's start by constructing a counter. Let's say that we want to create C1 is a counter. So just use the name of the class. We're not going to pass in any value. And then let's just say we want to print it. We want to print C1. See how that looks. Okay? So let's give this a run. See what we get back. And what you're going to see here is the default behavior when we print an object is we see what object we're in. We see what object we have. We see what it's an instance of. It's an instance of the counter class. We can also see that it's in something called main, which is the run of our module. And we can see that what we really have here is probably some expression of the address in memory where our counter object is. Well, that might be interesting to technical people, but it's not what we had in mind. If you look up on line 11 in my comment there, we were looking for something that would say it's a counter and here's what the values are internally. Okay, so we're going to need to provide a stir method, and that's another one that comes with the underscores. So you can't call it explicitly, you have to call it implicitly. When we, in our test, said that we wanted to print it, we implicitly called the method. So why don't we go back up and create an explicit stir method. So under stir. Okay, and you can see it knows that standard name for string. And let's be funny. In the short one, let's just say this: we're going to return hi mom. That's always my favorite kind of throw a string there. Kind of a shout out to my late mother, who I miss very much. And so let's run that test again. And we get a hi mom. Still not useful, but we can see the plumbing here. This is the method that gets called when we try to get a string representation of the counter object. So what can we do to give out a proper representation of the counter object? Well, what I want to do is I want to create something that looks like what I put on line 11 in the comments. Okay, so I want to begin with the name of the class, and then I'm going to put I've kind of copied this style from I've kind of borrowed it. Okay, and maybe adapted it a bit, but just put each of the instance of variables in there, show their name and equal sign and the value. And I've got sort of liberal use of spaces there because I'm going to use a trick. I'm going to build the message in a list, and then I'm going to join the parts of it with the join method of the string. And this is a typical way in our class that we've been creating messages that doesn't take as much concatenation, which is comparatively less efficient. So we're not going to say hi mom, okay? But we are going to do something like this. We are going to let's say the message is going to be built in a list, and when we start it's empty. Okay, and let's append each part in turn. So we want to say message append, and we want to begin by just saying counter. All right, that's the first thing that we want. And because of the way we're going to join these, I'll get a space after that because I'm going to join on the space character. And now I want to put together the first value, which of course is a value itself. So let's see, I wanted a square bracket, and I wanted to say value, that's the name of the instance variable, space equals, okay, and that'll get that out there. And now I'm going to append again, and I want to get the value. So the value is currently an int, and I want to turn it into a string. So let's just be explicit here. Let's say str of self under value. Okay, so that's good. So now I've got the value there, but I also want my closing square bracket. So I usually do here is I say plus closing square bracket. And now I'm going to do the other one, which is a start value. So message append, and I'm going to begin with a start value, and I'm going to give a space equal, and now I'm actually going to put it out there. It's got a message append again. So again, I want the string representation of the int start value. So I'm going to say stir and pass it self dot start value, and that's a good start. And I just want to make sure that I append the closing square bracket on the end, and that's going to do it. Except that it's I'm just going to do my trick where I turn it all into a one string with the join. So I'm going to return and I'm gonna use the space string and call join on it, and I'm going to pass in the list message, and that's been our standard kind of pattern for how to build a message, at least in the latter half of our Python class, and that should do the job. So let's see if we do this again. If we look back, let's look down to our test code. Right now we're creating a counter C1 and we're trying to print it. And the last time it said hi mom, but now we should probably see start value 0 and value 0. So we haven't done anything to it yet. So let's do that. And that's what we got. That's very nice. So it said counter value 0, start value 0. Okay, so that's much more appealing than what we got built in. Okay, to know that we have a counter object and it's a certain location in the memory is kind of technically interesting, but not really, it doesn't create a lot of end user value or even any good programmer value. All right, so we've got that, and at this point we have all the code in the class that we need. Now we just have to do a better job of testing. So what I usually do down here in the main is I just run a bunch of test cases, okay, and I begin by saying something like this: class counter unit test output follows. All right, I usually print that. And that's testable as it currently is, so let's give that a test. Yeah, class counter unit test output follows. It looks good. So now I want to do my first test. Okay. And what I usually do is every test skips a line before you see the output. So the first thing I have in my string is \n to skip a line, and then I'm gonna say what test case this is. Test case 1. Okay, and what do we want to do? I want to construct a counter with no initial value passed as a parameter. Okay, so we want to just want to call it with no parameters. Okay, and we're going to see what we get back. All right. So let's do that. Let's create the variable C1, and let's construct a counter. We're not going to pass anything in. We're going to expect it to take the default value of 0, and we're going to say the expected value is equal to 0, and we're going to say that the actual value is equal to call the getter for value, call get value on C1, which should also be equal to 0. And then let's do this trick. This is what I try to do here is to emulate the kind of comparisons that are done in the more robust kind of big time testing frameworks. So what they usually do is you predict the output, and then you compare that to what you actually get, and then you send back some kind of indicator that it either passed or failed. In these big testing frameworks, you typically get some kind of a graphical indication in red and green, and you can run a whole bunch of tests at one time and not really have to look at them. just see if in the aggregate they came back green. Well, this approach that we've been doing in my class isn't that sophisticated, but it gets the job done. So we say if the actual equal the expected, then we're going to print past. Sorry, not capital print, but print past. Else, we're going to print failed. And we're going to expect this to pass. So we're going to run this. Again, we're going to expect to get back a pass on this one. So let's do that. And we run it. And let's look down here. Let's make that a little bigger. Test case 1, construct a counter with no initial value passed as parameter. Passed. Very nice. So we got the value set to 1. All right, that's good. Now the next thing I'd like to do is I'd like to construct a counter and pass in an initial value and see if that's going to work. So let's see. Now, what I usually do is I clone one case into the next. It's kind of lazy, but effective. Okay, so in test case 2, let's say construct a counter with an initial value of 250. Okay, so first of all, we have to do it. I tend to just reuse the variable names. I mean, I'm kind of done with it from up here. I mean, you could change them, but it makes it a little bit harder to clone the code. So I just reuse the variable names. I'm going to give it and pass it in an initial value of 250. I'm going to expect that that's going to be 250 when I get the value. And let's just see if that passes. I'm expecting that to pass. So let's give it a run. And that ran too. Very nice. So construct a counter with initial value of 250, passed. Well, that's beautiful. So what do I want to test next? Okay, let's see if the click works. Okay, now how does the click work? Well, whatever with the current value is, we expect it to go up by 1 for every click that we pass. Okay, so let's just take the last test case 2, and clone it into test case 3. Okay. And what are we testing here? I'm just going to say test click method. Okay. All right. So we can construct it again at 250. And let's do 2 clicks on it. So C1 click. And C1 click again. And now we're not expecting it to be 250, but 252. But I just want to show you every once in a while. Well, in fact, in modern testing approaches called one in particular called test-driven development, people want you to, number one, they want you to write the test code first, which is I think a great idea, but I will admit it's an acquired taste. But the thing is, the first test you run, you want to force it to fail. Well, here we get a chance to do that because we're predicting the old value, and it should not come back with that. So let's just see that we do get a fail on test case 3. So let's look. Test case 3 did fail. Okay. Well, that should be 252. All right. So we change the test case and we run it again. And now test case 3 has passed. Well, that's great. That's just what I want. Now, do I need any more test cases? Well, I think I do. Okay. One of the things that I need to do is I need to be able to do a reset and get back to the value that I had. Okay, the original value. Okay, the original value is kind of hidden in there. Okay, so I could do 2 tests of this. I could make sure that I set that I'm able to reset when I take the default start value of 0, and I could make sure that I'm able to reset after I've passed in another start value. But knowing how the program's constructed, which I do, those are both going to work equally well. So I feel entitled to just have one test case for reset. And to be kind of fancy, I'll test the one where we passed in the 250. So I'm just going to take test case 3, which has a lot of what I want, and clone that into test case 4. So let's do that. Put in test case 4. So there's our, got too many blank lines there. Test case 4. We're going to test reset method. Okay. Okay. So let's do this again. We're going to be able to force this one to fail right away too, because we've got it expecting 252. But before we get there, let's do a reset. Okay. And now it should be back to 250. So 252, as expected, is going to force a fail. So right now I'm going to expect the test case 4 to fail. Let's see if I can make that happen. Yep, test case 4 failed. Very good. And now let's put the proper value in. 250. We've come to. And let's run the test again. And that test has passed as well. So test case 1 passed, 2 passed, 3 passed, 4 passed. Okay, am I done? Well, no, I do have one other method that is untested yet. Let's take a look up there, okay? So I tested the constructor both with the initial value and not, so that's good. I tested the reset. I tested the get value because we used that several times. I don't feel that I need to test things like a get value explicitly if they're being used in my other test. So they're tested kind of implicitly. Click worked, but we haven't done the string method yet. Okay, so here's what we're going to do. We're going to test that in the following way. Okay, we're going to clone a test that we already have, and I'm going to show you my usual cheater way of testing a string method. It's served me pretty well over the years. So this is test case 5. Okay, and this is going to test the string method. Okay. All right. So we're not going to do anything about expected values for those things. So let's take, first of all, let's take the passed and failed code, and let's put that into a comment for a minute. Toggle that into a comment. Okay, I know I've done that, and I don't have to do the expected and get the value. Okay, and I don't need all these clicks either, so that's fine. So I've got a value of 250. Oh, I could use a click. Let me go back. Okay, so let me, sorry, didn't want to do that. So let's take out some of these, but not all. Let's put 2 clicks on it. Okay, that'll have to get it to 252. Then the value of the value and start value should be different by 252 for the value, 250 for the start value. And let's do this. Let's just see what print does here. This is a part of my finely honed test cheating or efficiency scheme. Okay, so we have that, and let's give that a run, and look what comes out down the bottom. Okay, so let's make this a little bit bigger so we can see the detail. So I got a counter, and then value 252, that looks right, start value 250. So what I usually do is, by doing that kind of a print, I'm really inspecting the value visually. In most test frameworks, okay, you can keep your tests and you can accumulate them, and you can run them in a way that you can run tests for all of your classes. You can run all of the unit tests, and it will tell you if they all passed or not. And you don't have to inspect the output of any of them, because you predicted the output and you compared it. So what I want to do is I want to take a visual test here and turn it into that kind of a comparison test like we just had. And how do I do that? Well, what I'm going to do is I'm going to say what the expected is. So I'm going to say expected equals some kind of string. Well, I'm just going to take the 1 out of the console here, because I've already verified through inspection that this is the proper value. Okay, and so I'm going to paste it in to the expected value here. And of course, when I do the comparison, and then I'm going to say, well, instead of print C1, I'm going to say actual gets, we're going to use the stir or string method for C1. We're going to call the string function on C1, and that's going to exercise the method that we're trying to test. Okay, so we have that, and now we just have to take the typical code back here. We just have to reinstate if actual equal expected. So I'm going to toggle that back on, and I'm going to get rid of my extra lines, and that should do the job. So let's see. We did it by visual inspection, and now we're going to report back pass, I would assume. So let's do that. And now we're going to run it. And test 5 has also passed. So very nice. The good thing here is, and this is really true when you're trying to you're trying to test, you're trying to predict the value of some kind of convoluted print output. You'll do just as well to visually inspect it and then copy that to make your test more automated for the long run. But trying to build up the same expression into the expected can take a whole lot of work, and it's not really worth doing. So this little cheat or time saver trick is really just what the doctor ordered. So this is it. This does the job. And of course, the code that we have here in the main is just the unit test code for the counter class. It's probably not a great place for it. I mean, it is. We probably would do better to adopt a more robust testing framework. But the kind of logic that we used here is really consistent with all the good Python testing frameworks. So I think we're well on our way when we want to refactor to doing that. Okay, so let's run one more test again to make sure that we pass all 5. And let's see, 1, 2, 3, 4, 5, all passed. That's good. Now the other thing that I would like to do is I would like to go up and check the code with the code inspector. So I'm just going to code inspect and just this current file. And let's see how we do. And let's see, we have one spelling typo. Initial is misspelled. So let's find that. Yes, it is. So let's say that we want to change to initial. Okay, that's fixed. And we had Python 2-week warnings. Let's look at that. It says our list creation can be rewritten by a list literal. And I'm not going to do that yet, but I'll show you how that can be done. And we've got one more PEP 8 code style evaluation. Too many blank lines, and where's that? Oh yeah, we've got too many blank lines between the class and the main. They just want 2. They want exactly 2. So let's give them 2. All right. So that should give us the style that we want. So let's try this one more time. We should just be down to that one complaint. Inspect the code for the file. And this is it. We're just down to this list creation could be rewritten as a literal. So what they're saying is that this kind of step at a time thing I've done to build up the list, which is, I think, really makes for easy coding, right? And pretty good documentation. They're saying you can maybe create more efficient Python. And how could you do it? Well, you could do it all in one statement. Well, how's that? Well, let's see what that would look like. So I'm just going to double click on this, and I'm going to say, okay, let's see it. Replace list creation. And now it's been done for us. Let's just take a look at what the code looks like. Okay, so it's the same code, all right, and it's maybe better code, and you might like this style better. The problem that I have is if I go back and add some kind of another instance variable, I don't know what feature that would implement, but let's say we did, and I wanted to change the string representation of it, it'd be pretty hard for me to revise that. So I kind of like leaving it. I'm going to undo that. I kind of like leaving it in a little bit less efficient mode, which makes it, I think, easier for me to maintain. Your mileage is going to vary. I don't feel that strongly one way or the other. Okay, so that's it. This is what we're looking for. I think I would take this kind of list of requirements out because we don't want to maintain them. Okay, and now we've got 2 blank lines there. So I've made some change. So every time I change it, no matter what, I want to run a test. So let's run a test again. And let's see, pass all 5 of my tests. And I've changed it again. I usually like to go back and inspect the code one last time. And let's see what we've got. And we've just got that one complaint about the list, which I've decided I am going to leave there. So that's it. That's a pretty simple object. Again, we've taken a fairly conservative approach. The instance variables themselves are, a lot of us like to say they're hidden when we put the double underscore before them, but they can be seen. And they could also be changed if somebody wanted to be diabolical. But what we've done is really strongly hint that we've encapsulated the data in these instances, and if you want to interact with the data, you're left to call the methods, which are the formal interface of the class. And again, by Python standards, that's a little strict. That puts me in the conservative camp, who by some would not even be called a Pythonista, okay? But I think it's good software engineering, and I want to get everybody off on a good foot. So that's what I'm going to recommend that you start with. So good luck on creating your own class. Until next time, bye-bye.